Okay, so Chapter 8 is known as Joints and Movements. And the study of joints is called arthrology. So an arthrosis is a joint. We also refer to joints as articulations. Um, Most joints are between bones, between two or more bones, and they allow movement. Some joints actually don't allow movement, for example, sutures. But most of the joints we're going to study in this chapter allow some type of movement. So then the study of movements is known as kinesiology. So we're doing arthrology and kinesiology in this chapter. And if you're going into a medical area such as physical therapy, this is going to be a particularly important chapter for you. Physical therapists' expertise is in bones, joints and movements, muscle, and nerves. So let's take a look at some of the topics we're going to cover. First slide we're going to do is classification. So there's a lot of different ways to classify a joint. You do it based on the amount of movement, which is a pretty general category. You're either immovable, like a suture, or you're freely movable, like a synovial joint, or you're somewhere in between. We call that slightly movable. Then we're going to look at categories that classify joints based on the structure. And that's particularly the material that holds the bones together. You could be irregular connective tissue, you could be cartilage holding bones together, or for the synovial joints, it's ligaments that hold the bones together. Then we're going to also include what we call range of motion. So then we're going to take, once we learn how to classify joints, we're going to take the three structural categories and look closer at those. So they are the fibrous joints, the cartilaginous joints, and then the synovial joints. So those are three categories based on structure. We're then going to look at movements. So we're going to study mostly the synovial joints and what type of movement is allowed at that joint. So we're going to learn words like flexion and extension, abduction and adduction. We're going to learn about rotation and circumduction. So there's quite a bit of terminology used to describe the type of motion that occurs. Then we're going to look at 5 joints in detail. We're going to look at the shoulder joint, the elbow joint, the hip joint, the knee joint, and then finally the TMJ, or temporal mandibular joint. Okay, so let's begin by looking at classifications. So we're going to look first at functional classifications. So this is that amount of movement. There's 3 categories. If you are immovable, so the bones don't move, that's known as a synarthrosis. Synarthroses is plural. So an example of a synarthrotic joint would be the sutures of the skull. Then if you kind of jump down to the last one, you could be freely movable. So these are the joints that have the largest amount of movement. Those are called diarthroses, or a diarthrotic joint. And then if you're not immovable, yet you're not considered freely movable, you're somewhere in the middle. So the slightly movable joints are called amphiarthroses. All right. So that's based on, how much movement. Then we can look at the structure. So the structural classifications are based on what type of material is holding the bones together, and then is there a cavity? All right. And the cavities are all the synovial joints. So you've got irregular connective tissue. If that's the material, it's a fibrous joint. If it's cartilage, either hyaline or fibrocartilage, you're a cartilaginous joint. And then if you have a cavity and you're held together using ligaments, you're classified as a synovial joint. And those are the ones we're going to spend most of our time learning about. And all synovial joints are classified as diarthrotic. All right, they're freely movable. But they too have different categories. The range of motion, we've got 4 categories there. And the range of motion has to do with how many planes do the bones move in. If they just slide a little bit and there's no angular change to them, it's called non-axial. And the type of joints we're going to look at are planar joints. Uniaxial is movement in one plane, like a hinge joint. There are some joints that move in two planes, which are biaxial joints. Those are the condyloids and saddle joints. And then finally, if you move in all three planes, you are a multi-axial joint, which are the ball and sockets. So these four categories all describe the range of motion of the synovial joints, which are all freely movable. Okay? So again, this is a lot of terminology. Looking at a particular joint, do we know, the amount of movement? Do we know the structure and what holds the bones together? And then do we know the range of motion? Okay, so then we're going to take those structural categories and expand on them a bit. So if we just take a brief look back, we're going to look at these three categories, fibrous, cartilaginous, and synovial, and take a deeper look at those categories. So for example, if you're a fibrous joint, you're one of these three. And what makes you different is basically what does that cartilage or connective tissue look like? All right, so you're defined by bones are held together with irregular connective tissue. If it's very thin and therefore it holds the bones very tight, you are a suture. So the sutures of the skull that we learned in the previous chapters, such as coronal, sagittal, lambdoid, if you remember the squamous suture, those are all sutures, but a suture is a fibrous joint. And all those sutures are immovable. So if we go back here, they are synarthrotic, or immovable joints. The next category under fibrous joints are the syndesmoses, or a syndesmosis. Here, the connective tissue is a little longer. It forms kind of a band of connective tissue. And these are found in between the bones of your forearm. So this is the radius and the ulna. And also found in between your tibia and fibula of your leg. And these are known as interosseous membranes, because the sheet or the band of connective tissue forms kind of like a membrane that's in between bones. So inter means in between, osseous means bone. The connective tissue forms a membrane. So this is called a radioulnar syndesmosis. And these are slightly movable. These bones will kind of turn a little bit. All right, this is not an immovable joint, so we would classify that as amphiarthrotic. Then we got the gomphosis. The gomphosis is a peg and socket joint. Just so happens that what holds the peg, in this case a tooth, in the socket is connective tissue. So these are little connective tissue bands here holding that tooth inside that socket. So not all joints are bone and bone connections. This is a tooth and a bone connection. All right, so then we're going to take cartilaginous and break that into two categories. You have the synchondroses and the symphyses. A synchondrosy is hyaline cartilage holding the bones together, where a symphysis or the symphyses are fibrocartilage. All right, and some of these go away. So growth plates are actually a joint until the cartilage goes away and it forms a line. So if you're still growing, right, and you have epiphyseal plates, that plate is hyaline cartilage. So that's technically a type of joint. It's a type of synchondrosis. All right. They're also found in the hips before the hip bones all fuse together. Right. The ilium, the pubis, and the ischium are all held together using joints until they're fused. And then here we see a joint between the sternum and a rib. So that's called a sternocostal joint. And that's a type of synchondrosis because it's hyaline cartilage. And then even this would be considered a joint between the rib and the cartilage here. But pay attention to this one here. A sternocostal joint, because that's hyaline cartilage, is considered a synchondrosis. We're going to learn one symphysis. It's called the pubic symphysis, where the two pubic regions of the hips are held together using fibrocartilage. So the key to a symphysis is the bones are held together with fibrocartilage. All right. So cartilaginous joints are a little confusing because a lot of times you think like the knee joint must be cartilaginous because you've heard about cartilage in the knee. But the cartilage in your knee is not holding the bones together. It's ligaments. So the knee joint is a synovial joint. It's not a cartilaginous joint. Okay. Let's look at synovial joints. So that's the third category under that structural classification. And this is kind of your basic starting point when learning synovial joints. Every book uses something like this to kind of introduce some of the characteristics that synovial joints have. And then we take this and we'll apply it to, say, the shoulder joint. And we'll try to find all these things in a shoulder joint. Then we'll look at the knee joint and kind of try to find all these things in the knee joint. But synovial joints have a articular capsule which forms a cavity. So notice here's a capsule here that completely surrounds these two bones that come together. And inside that cavity, there's going to be synovial fluid. So let's go through the main characteristics of a synovial joint. They're all diarthrotic, meaning freely movable. They have cartilage, but again, the cartilage is not holding the bones together. It's protecting the ends of the bones and providing a nice smooth surface. All right, so this is hyaline cartilage known as articular cartilage because it's found at a joint or an articulation. There's a capsule surrounding where the two bones come together, or three, there could be more. And that capsule has a couple layers to it. It has an outer fibrous layer, and then it has an inner synovial membrane. So the membrane on the inside, together with the fibrous on the outside, forms what's called the joint capsule, or articular capsule. Inside would be the cavity, and inside that cavity there is synovial fluid. All right, synovial fluid provides a few functions. It's going to lubricate the joint, right? So now you have a nice lubrication in between the two articular cartilages. It supplies oxygen and nutrients to the cartilage, because remember, cartilage is avascular. It doesn't have any blood vessels. So it gets its oxygen and nutrients from the synovial fluid. And then it also provides a little bit of cushioning. A little bit of shock absorption in between the bones. So synovial fluid is very important. It's vital for the proper functioning of a synovial joint. And then you've got ligaments. All right, so there's a lot of different types of ligaments. They're going to help, obviously attach bone to bone, but they also will, depending on the joint, they might prevent certain motion that you don't want to occur. And then they'll reinforce or stabilize that connection. And under the heading of ligaments, that you could be three types. So you could be part of the capsule itself. So those are known as capsular or intrinsic ligaments. So for example, this would be considered a ligament, this fibrous capsule here, because it's attaching bone here to bone down here. So it's part of the capsule, but it's functioning as a ligament. You could be outside the capsule. Those are called extracapsular ligaments. All right. Some examples of extracapsular ligaments are going to be the collateral ligaments. You've got collateral ligaments that are on each side of, say, the knee joint or each side of your elbow joint, and those are found outside the capsule. And then you might have intracapsular ligaments. Those are found actually inside the cavity or inside the capsule. And when we get to the knee joint, the cruciate ligaments are intracapsular. You've probably heard of the ACL. Well, that's a That's called the anterior cruciate ligament, and it's found actually inside the joint capsule. There's also one in the back called the posterior cruciate ligament. All right, what else do joints have? They have a lot of nerve supply and blood supply. You can see that here. So you got to have blood supply to the capsule. You obviously got to have blood supply to the bones, and there's also nerve. There just isn't that in the cartilage. So this cartilage doesn't have nerves or blood supply. You could have some other things. You got to have a lot of cushioning in and around a joint. If joints are moving quite a bit, right, and you've got bones moving, you got to protect some of the soft tissue that's found around that joint. So you got to protect tendons. You might have to protect the ligaments that are surrounding the joint, and there's a few structures that allow that protection. One of them is a bursa. So a bursa is a fluid-filled sac that might cushion, a tendon. You don't want the tendon kind of sliding up against the bone, so you can protect it there. And then you might wrap one of these bursa right around the tendon. So it's kind of a fluid sheath that surrounds a tendon. So here's a tendon, and then this sheath surrounding that tendon is going to protect it in the area of that joint. So these are all kind of your basic components of a synovial joint. When we look at specific joints like the shoulder, elbow, hip, and knee, we're going to probably find all these things and then even a few additional things in those joints. Continuing with synovial joints, there are 6 categories of synovial joints. And what puts you in these categories is the shape of the bones that come together. Okay, so if the two bones come together at very flat or slightly curved surfaces, that's called a plane or planar joint. For an example here, they show the joint in between vertebrae, but you also find a lot of these planar joints in your wrist, so intercarpal, so in between carpal bones, and then also in between tarsal bones of your ankle. So the bones come together, they're fairly flat, and what they do is they just slide a little bit. We call that gliding movement. There's no change in the angles, all right? So they just kind of slide back and forth. And those are known as non-axial joints because there's no movement in a plane. They just slide back and forth. The next category are the hinges. So hinge joints include the elbow joint is a hinge, the knee joint is a hinge, the joints in between phalanges, so like right here is a hinge joint, that's a hinge joint there. Hinge joints allow movement in one plane, so they're known as uniaxial. They allow flexion and then extension. And we're going to learn what that means, but basically if you think of your elbow, when you bend your elbow, that's flexing. And then when you straighten it back out, that's extension. All right. So the hinge component of your elbow is between the humerus and the ulna. That provides a nice hinge. There's another joint in your elbow right here between the radius and the ulna. So notice over here, here's that ulna, here's the radius. This is a different joint. This is called the proximal radio-ulnar joint because we're at the proximal end between the radius and ulna. That's actually a pivot joint. So a pivot joint, you have a ring and then something in that ring. And either the ring rotates or the bone that sits in the ring rotates. So pivot joints allow rotation. Rotation is basically when a bone kind of spins. All right? So what bone spins here is your radius. So when you turn your palms over, that's a type of rotation. And that's happening when your radius rotates over top of your ulna. All right? So pivot joints allow rotation. The two I want you to know is this one here, the proximal radio-ulnar joint, and then the joint between your atlas and your axis. Remember, the atlas is the ring. The axis has that dens that sticks up, all right? So it kind of would work similar to this, but it's not the axis that spins, it's the atlas that spins, All right, so pivot joints are a ring and something in the ring. In this case, it's a ligament that forms the ring. This is a ligament that forms the little ring, and then the radius rotates. All right, so pivot joints allow rotation. The next two are fairly rare. There's a few examples of condyloid joints I want you to know about, and then there's really just one saddle joint I want you to know. But these are allow a little more movement than, say, a hinge joint and a pivot joint. They're going to allow flexion and extension. They might also allow abduction and adduction. What they don't allow is any rotation. So if you're going to rotate, you're going to either be a pivot or you're going to be a hip, or I should say a ball and socket, which the hip is an example, and so is the shoulder. So a condyloid joint, if you compare this drawing to this drawing over here, they're very similar to a ball and socket, but instead of a spherical ball, it's an oval ball. All right, so condyloids allow almost everything a ball and socket does except rotation. All right, it won't allow this to spin or rotate. The two condyloid joints that are, the most kind of famous ones that people know about is the atlanto-occipital joints. So that's between the occipital bone and the atlas. And then the radiocarpal joint. So that's between the distal end of your radius and a couple of your carpals. All right, so if you take your wrist right now, you can flex it and extend it. So you can kind of bend it and then straighten it out. You can move it side to side. That's abduction and adduction. You just can't rotate it. You can't spin that hand around at the wrist. All right, so it doesn't allow that rotation. Saddle joints, I want you to know one of them. Saddle joint, one bone forms kind of a saddle shape. These do a lot of the same things as a condyloid. They allow almost all the motion a ball and socket does except rotation. And the example here is found right here. So that joint is between your first metacarpal and the trapezium, which is this carpal right here. So that's kind of the most famous saddle joint in the body. There's a few other ones, but that's the one I would like you to know. And then finally, you have the ball and sockets. Those are going to allow the most motion, so they're going to allow flexion, extension. They're going to allow abduction and adduction. They're also going to allow rotation. You can spin the ball in a round socket. All right, so they allow all the different angular movements. And for that reason, they are considered multi-axial joints. And you got two ball and sockets. You got the shoulder and then the hip. All right, so that ends the first video. What did we do? We classified joints. We classified them based on the amount of movement, the structure. We added in these uniaxial, non-axial, and biaxial, and multiaxial traits. And then we took and expanded on the synovial joints. The next video, we're going to look at movements. So we'll review all this terminology used to describe the movement at synovial joints. And then we'll probably have the third video where we get into the specific big five, I call them. We'll get into your shoulder, elbow, hip, knee, and then end up a little bit on the TMJ. All right.